Welcome to our program, Astronomy for Everyone. Our program for this month is entitled Getting Started in Meteorite Collecting. And with me here in the studio is our special guest, Mark Jeffrey. Mark, welcome to the show.
Thanks, Don.
Now, what inspired you to start collecting meteorites?
Well, Don, I guess part of it's the journey that these meteorites took. They started off as stardust, billions of years ago, and they went and spun around our sun, and they became planets and asteroids and moons. And after all that time, they got knocked out of their orbits, and somehow they ended up crashing through Earth's skies. And now I can hold one of them in my hand, and I think that's pretty amazing. And I think that's the first thing that got me going on meteorites.
Again, that history, if you will, the backstory to the piece of rock, if you will, in your hand. Now, what are the basic types of meteorites?
Well, Don, the three main types we call irons and stone and stony irons. And the irons came from bodies that were really big and melted on the inside, and all the iron sunk to the core, and the stone floated to the top. And right where they touch in the middle, where they melted in the iron and the stone, you get the stony irons. And that's the three main categories that we have.
Now, the irons, are they all pure iron, or is there a little bit of mix of some other metal in there?
Well, meteorites almost always have iron mixed with nickel, and they're anywhere from 85 or so to 95% iron. They've got the nickel, and then they've got some small trace elements.
I see. All right. Now, how do you know if a particular rock is a meteorite? I mean, what should you look for? Well, it used to be that you had to see it fall because they didn't have any other way to judge whether something might be a meteorite. If it came out of the sky and dropped on the ground, then you knew it was a meteorite. Now we've got science to help us out and a lot of history, and so you can have it analyzed, but most of us don't have those kinds of tools available. So the first thing I'd look for is the thing really heavy? And I've got an example here of a meteorite. They always feel, the iron meteorites especially, feel very heavy. And if you pick one up, you'll just say, wow, that's pretty hefty. Another thing an iron meteorite has is it has these little thumbprints in them. They call them rigmoglyphs. And those thumbprints are very characteristic of an iron meteorite. And one final thing to look for on these things is if you cut them open and you polish them and etch them, you'll see this pattern on them. And that pattern is called a Widmanstätten pattern. And I'm sure somebody with some German could say it a little better. But that pattern is unique to meteorites. You wouldn't see that in any Earth rock. And that's one of the best tests to see if something really is an iron meteorite. A unique characteristic,
yes,
characteristic to separate an Earth rock from a meteorite. Anything else?
Well, if it's a stone meteorite, it's going to have some crust on it, like this one has, this thin black crust. If it's a thick crust, it's not a meteorite. It's always going to be thin and black, and that's because it heated up when it went through the atmosphere, and it caused the outer skin to sort of evaporate. Another characteristic of a stone meteorite is it might have these metal flecks inside, and the metal flecks are the iron that's inside the stone, and it hasn't completely melted out of it yet. So it'll show up in various places. And if you cut something open and polish it up and you see those metal flecks in there, that could mean it's a meteorite. And finally, the last characteristic I'm going to share of a stony meteorite is what we call chondrules. And those are little spheres that are attached together that make up the meteorite, and that's for meteorites that have never melted. If they melted, all that would disappear, and the iron would go one way and the stone the other way. These have never really fully melted, and so those chondrules are there. Now, the stony irons are the most pretty of all the meteorites, I think, and those have an iron matrix. You can see the iron all through here, and they also have the pretty crystals. They're peridot crystals or olivine, and if you put a light behind them, on these thin slices, the crystals will let the light show through, and they're quite striking.
All right. Again, the dark areas in that would be the iron.
Well, that's the shiny areas are the iron.
Okay.
And
the translucent would be the olivine or the peridot?
Right. Actually, the darker ones in this view from here, but if I were to put light behind it, it would show right through those crystals. and that would be it.
Now, a lot of times, people will walk along and pick up a rock and bring it in. I think one of the big things that they confuse for a meteorite would be slag from a foundry. Is this fairly common in your experience?
Well, when you look for meteorites in Michigan, it's difficult because there's so much iron around and there's so many rocks. A lot of them have a black crust on them, or at least they look like they could. So you tend to want to look for meteorites in places where a black rock would be an unusual thing. Like out in the desert, you see a lot of white sand, you see some black rocks. That's a good candidate. And so you'd be testing them with a magnet to see if there was iron. But it's pretty difficult in a state like Michigan. They kind of rust away after a while anyway.
Well, that really brings up my next question, is where can you find meteorites? You just touched on it briefly, but if you could expound on that a bit.
Well, a lot of them are found in places like Antarctica on glaciers because they have lots of white snow and ice. And when you find black rocks, that's a good indication that maybe you've just found something from outer space. When you get out in the west, in the drier areas of our country, people often go out with their strong magnets and go out for a walk in an area where they've known meteorites have fallen in the past. We call those strewn fields, areas that are covered with meteorite fragments here and there because something blew up over it in the past and there's lots of little fragments. We saw that in Russia just this past year. They're still finding little pieces of that meteorite all over the place. So if you look in the right places in a dry climate, you have a chance.
I notice in the TV show Meteorite Men, they always seem to be out, as you indicated, in the more drier regions of the country to look for these. Now, earlier we talked about, in your introduction, I think it was, talked about what inspired you and these rocks coming from these various bodies. These are caused by collisions with these bodies that break off these small chunks, and, well, how do they end up here at Earth?
Well, a lot of the things that started off as asteroids are what end up as meteorites on Earth. And a lot of times it's Jupiter kind of being such a large body kind of kicks them out of their orbit for whatever reason. And sometimes they just crash into each other and disturb their own orbits. And that gives Jupiter a chance to kick them out too. But once they get pushed out of their nice circular orbit into elongated orbits, they may sooner or later pass by Earth close enough that Earth's gravity starts to pull them in. And after, you know, a number of rotations like that, they kind of get nudged towards Earth, and then eventually they can hit Earth. Some of them, though, are meteorites we have are from the Moon or Mars, and those are knocked off by some large meteorite that hit those and knocked them off, and eventually they end up on Earth.
The meteorites arriving here, do they typically explode in the atmosphere, or would they land in a solid chunk as a big thud? Or
well, we've got some that are like 60 tons of a solid meteorite. We've got other ones that exploded and we never found any crater at all because they exploded high enough up in the atmosphere.
Such as the Russian
for example. But that one was a little bit mixed. They did find a pretty good size 1,200-pound chunk in the bottom of that lake where we saw pictures of the ice. They finally brought up a chunk of that. So a lot of times the largest pieces make it to the ground, and a lot of other pieces just get scattered all over due to the explosion.
Interesting. We're going to take a short break here in our discussion. If you have a question, please send us an email. You can see the email address down at the bottom of your screen. And after we break for Term of the Month with Stephen Whitty, we'll be back with more about meteorite collecting.
The term of the month for January 2014 is Hines Crimson star. Now, this star also has another name, R. Leporis, and it's found in the constellation Lepus. Now, Lepus is the hare, and it's right underneath Orion the Hunter, right underneath the feet of Orion the Hunter. It is an unusual star. It is red. Now, in this picture, which is in black and white and massively overexposed, you're not seeing that it's red. But what you do see in this image is that a little up and to the right, there is a pair of stars with a sort of little curve underneath it, and it's a curve of 3 or 4 stars. And this is something to help you find Hines Crimson star when you're looking through a telescope or binoculars. It may not be on the upper left, it may be around somewhere, but it should be quite nearby. I picked this star not just because it's red and unusual, but because it's going to be very bright in the month of January. So I saw it last year. It was magnitude 10, which is quite faint, but during January it should be very close to naked eye, just barely naked eye visible, magnitude 5.5. Now if you're at a dark sky site, you might use your naked eye, but I would recommend binoculars or a telescope. R.J. Hind found this star, which is why it's called Hines Crimson star, and he called it a drop of blood. But when I looked at it, I thought of it as one of those red LEDs that you use for cat's toys or maybe for presentations. It's that red. It is entirely red. Now, the next image is this light curve, and this light curve was put together by the AAVSO, the American Amateur Variable Star Observers. And you can tell from this curve, or by looking it up on Wikipedia, that it has a 14-month loop, and from that I was able to figure out that this January it would in fact be bright. So we have Mag 5.5 at the top, that's bright, and it can go to Mag 12 at the dim side. Now, Wikipedia has a finder chart for Hines Crimson star, so that's Lepus, the constellation, and you can see right at the top Orion, and to the right there Rigel, the very bright star Rigel. And off to the right there's an R with a little circle next to it, and that is where you actually find Hines Crimson star. There is also a galaxy, NGC 1710, which is right there. It's right, maybe an eyepiece field away from Hines Crimson star. So Hines Crimson star is just up and to the left of it. Now when you do find it, it is bright red. It is so obvious. There isn't anything else that's red. Red stars are quite unusual. Now, it's redder than just a red supergiant star, and that's because it's a carbon star, and carbon stars have carbon in the atmosphere, and the carbon absorbs the blue light from the spectrum, leaving just the red. So the term of the month, Hines Crimson star.
Welcome back. We're here talking with our special guest, Mark Jeffrey, on how to get started in meteorite collection. Now, Jeff, we talked a little bit earlier about the types of meteorites and what to look for, but do you have to find meteorites yourself to collect them, or is there somewhere where you can buy these items?
Well, most people don't have a good opportunity to collect their own. You have to kind of live in the right place, and you'd have to travel into some pretty rugged territory. So most people who collect meteorites find them on the internet or at shows, rock, gem, and mineral fossil shows. They can find meteorites. And there are a lot of dealers on the internet, and there is a committee that decides whether or not things are really meteorites or they're not, and they get assigned them an official number. And if something has an official number and it's being sold by a reputable dealer, then there's a pretty good chance you can count on it being a bona fide meteorite and not what we call a meteor wrong, which is no meteorite at all.
Exactly. So people, if they buy from these reputable dealers, have a reasonable assurance that they're getting a genuine article and not a piece of foundry slag.
Yes. And part of being a member, too, is that you vouch for with your reputation that what you're selling is, in fact, a genuine meteorite.
Now, when you look to get started in this hobby, what types of meteorites should a person start with?
Well, we usually recommend that you start with one each of a iron and a stony iron, and you don't have to get anything really fancy. You find something whose shape or color or whatever appeals to you, and for a very reasonable amount, you can have your own your very own piece of outer space.
Now, is there collectors, say, who collect a particular type or a look or a particular, what's the word I'm looking for? A certain feel or a type of meteorite that would separate it from other types of meteorites? I know you mentioned the three basic type, but are there unique attributes, I suppose is the word I'm looking for, that people would collect?
Well, you know, the kind that people like is sort of as varied as there are people. And, you know, I've got pieces that are of historical significance. I've got pieces that are of scientific significance. I've got one that I just like the shapes. I've got some I just like the colors. And if you'd like, I could show you a few of those, and you'd get some feel for what kinds of things you might be looking for. There's always a story to go with every meteorite, and typically people find a look and a story that appeals to them, and that's what they go for.
I think if you have a few of those examples, I think our viewers would like to see those.
Okay, well, let me start with one. This one is from Weston, Connecticut, and it was the very first meteorite to fall in the United States when it became a country. And it was very controversial at the time. In fact, there's a book that was written about it, and that book talks about, it's called A Professor, a President, and a Meteor. And many people trace the birth of science in America to the controversy and resolution of it scientifically that took place because of this fall of this meteor. So it had an important role to play both politically and scientifically in the early birth of United States of America.
So this would be one example of a historical meteorite, so to speak.
Yes, it would. I have another one, also historical. This is a sample of the first meteorite to fall in the Western world that we have a well-documented case for. This particular one, when it fell, people couldn't believe what had just seemed to have happened. And the political folks of the day came running over, and they thought it meant they were going to win in a war. Some people were afraid it was going to fly away, and maybe we ought to chain it down. But there was all kinds of odd things that people did when this meteorite fell. And the year of this fall is 1492. So Columbus wasn't the only thing going on in that year.
Interesting.
And here's one of scientific interest. This is called the Murchison meteorite. And this particular one has in it amino acids that are right and left-handed. And biologically, amino acids are only of one hand. So this would imply that these amino acid bases in this meteorite are non-biological origin, which is of great interest to scientists. And so they've done a lot of looking at this meteorite, trying to understand exactly what's in it and how they might account for it.
Very interesting indeed. Now, I've noticed with the meteorites that you've got here, they're in special cases or other types of protective areas. How should you display and care for your meteorites?
Well, because most meteorites have iron in them, one thing you need to do is make sure you keep them in a container that will have a desiccant in it to keep the water out of it, especially in Michigan. Our damp climate would keep a meteorite from lasting for a long time. It would eventually get rust on it.
As far as the other ones, just to keep them clean?
Well, even the stony meteorites, because they have a significant amount of iron, a stony meteorite will get rust spots on it if you leave it exposed. So almost all meteorites need to be kept under dry conditions. And you want them labeled, you want to research the story behind them and understand it, because most of the time that's probably what attracted to you in the first place, was the story that goes with it, and you want to display it so you can share your enthusiasm with your friends.
Now, I notice some of these are thin slices. Is there a problem with them perhaps breaking if they're handled roughly?
Well, the iron ones are not usually a problem, because even when they're relatively thin, the iron is pretty strong. But with stony meteorites, they can be down to 1 millimeter thick, and they're very easy to break if you don't keep them in their cases. Some are so thin you have to put them in special membrane boxes that hold both sides of the meteorite nice and tight. So yes, you have to be careful with them.
Now, what types of things should people consider when starting to build their collections?
Well, I've mentioned a few. I've got a few more here I could mention too. Some people like to collect the meteorites that are from their home state. And this particular set are 3 meteorites from Michigan. And there aren't very many from Michigan. There's probably only 8 or 10 total. So it's possible you could get at least half of those in your own collection. Some people would like larger samples, some people like smaller samples, but you can get into the hobby at a very reasonable cost depending on the size of the samples and the rarity of the meteorite that you're trying to collect. One other one I really like is some people collect shrapnel, which is a piece of meteorite that has exploded, in particular an iron meteorite. When the Russian meteorite exploded, we got a lot of little balls of rock, right? Well, when an iron meteorite explodes, you get some pretty impressive pieces of shrapnel, and some people will collect those. I especially like them because they remind me of the power and uncontrollability of nature when it's really going. Other people collect them because they're from where they're from. Like if it's from Mars, or it's from the Moon, or it's from Vesta, which is one of the larger asteroids, they might collect things that are just from those objects.
And again, with the scientific understanding and data we have these days, this can be verified that it is in fact from such as Vesta or Mars.
Yes, well, the Moon is an easy one because we've got rocks from the Moon, and generally we can test our chemical composition of our meteorites against the analysis on the Moon. But for places like Mars, we've got the Viking spacecraft that gave us an analysis of the rare gases on Mars. And if something has the same ratio of gases that Mars does, where else could it be from?
If it looks like a duck and quacks like a duck and walks like a duck, it's probably a duck.
At least a space duck.
There you go. There you go. Anything else you'd like to impart to our viewers in about the last minute that we have here?
Well, just to say that you can tell from the meteorites we've looked at today that there's a great variety of shapes and sizes and characteristics and history and stories that go along with these meteorites. So most people find something that just appeals to them as a person, and they come across something and they say, wow, that's really amazing. I would like a piece of that. And then they go for it. So you can collect almost any aspect that suits you.
All right. Well, Mark, we want to thank you very much for being our guest here today and informing our audience about starting their own meteorite collection. If you have any questions or want to find out more information, actually, you can go to our website. You can see that down at the bottom of your screen. We'll also include the website for checking out meteorite dealers that we talked about a little bit earlier in the show. Coming up next is Steve Whitty with What's Up in Our Night Sky.
What's up for the night sky in January 2014? Now, we just had the winter solstice, so the nights are long and the days are short. The sun rises at the beginning of the month around 8 o'clock and sets around 5 p.m., a little after 5. By the end of the month, the sun rises at like 7:45 in the morning and it sets at 5:45 in the evening. So the days have gotten a little longer, that is, the nights have gotten a little shorter. The moons this month are in the midweek, we'll just say it that way, and the month starts with a new moon on January 1st, and then first quarter is on the 7th, and third quarter, a full moon, is on the 15th, third quarter is on the 24th, and then we have a new moon, a second new moon on the 30th. So middle of the week you have the phase changes. Jupiter is in the constellation Gemini, And on the 5th of January, Jupiter is at opposition. That's when the Sun, the Earth, and Jupiter are more or less in a straight line. And that also means that Jupiter rises more or less around sunset, and it sets then at sunrise. So it is up in the sky all night long. And also, at about midnight, Jupiter is highest in the sky. It'll be in the south. And this month it'll be 70 degrees up, so it's really quite high. And this is absolutely great for getting your biggest telescope with your highest magnification and getting the most out of it. Now, I don't have a picture of Mercury, but Mercury has its maximum elongation at the end of the month on January 31st, at 15 degrees above the horizon at sunset. This is quite a ways up. This is quite a bit of elevation. So this is one of the easier times to see Mercury. So getting toward the end of the month, you know, maybe after the 20th and into the first week or so of February, Mercury is about as good as you can get. Mars rises around midnight, and it's in Virgo, and Saturn is in Libra and rises around 4 a.m. For both planets, these are morning objects. They're best at maybe 6 a.m. while the Sun hasn't peaked above the horizon or even close to the horizon, so it's still dark and you can still see them. So they're really good at 6 a.m. And you can see them more or less in the same view because Virgo and Libra are right next to each other. I'd like to take a look at the inner solar system for just a bit. So you can see in the upper left you have the Earth. Venus crossed, during the month, Venus crossed the Sun. So if you draw a line sort of between Earth and the Sun, a diagonal line, then anything to the upper right, that's an evening object, and anything to the lower left is a morning object. And Venus crossed from an evening object to a morning object. Now it's been really quite close to the Sun all month, so you're not going to see it. You can see Mercury is an evening object, it's up to the right, and then Mars is that morning object. And if you were to follow that line from the Sun to Mars out much farther, then you'd get out to Saturn, and so it would also be an evening object. And Jupiter would be absolutely in a line from the Sun to the Earth out to Jupiter pretty much all month also. Uranus sets at about midnight and Neptune sets at about 9 p.m. And so these are evening objects. They're both telescope or binocular objects. You need a good finder chart to get to them. And so I haven't given you images for that. They're pretty much where they've been all fall. We're going to lose them pretty soon because every month they set 2 hours earlier. So Neptune will set at like 7 in February, and Uranus will go to 10, and then a month later we'll start to lose it. So that's what's up in the night sky for January 2014. Be sure to look up because that's the greatest free show. It's overhead every night.